Good morning, students. Today's session will start learning about what is the transmission control protocol. Here, whenever you are learning about the transport layer protocols, there we should learn about the two types of protocols. One is the TCP, another one is the UDP. That is, the TCP is called the transmission control protocol and UDP is called as the user datagram protocol. In the last session, we have learned about the what is meant by this user datagram protocol. And in the first session, already I have explained for the connection-oriented service, we use the best example for the connection-oriented service is the transmission control protocol, and the best example for the connection-less service is the user datagram protocol. Okay, now we'll start learning about what is meant by this transmission control protocol. Now here, this TCP is a connection-oriented, reliable process-to-process transfer protocol. That means it is going to add the connection-oriented and reliable features to the services of the IP. Okay, and next here, whenever you're learning about the services of the TCP, here we should learn about the 5 services of the TCP. In that, the first one is the process-to-process communication. Then what is meant by this full duplex communication, and what is meant by this connection-oriented service, then reliable service, then stream delivery service. Now, we'll learn each and every service of the transmission control protocol one after the other. Now, the first one is the process-to-process communication. Here, the TCP is a connection-oriented service, and it is going to provide you the well-known port numbers for the transmission of data between the client and server. Okay, and the service is the connection-oriented. And now we'll learn about the different port numbers. Now, for protocol, the port number is 7, and the description for the protocol is echoes a received datagram back to the sender. And what is the discard protocol? It discards any datagram that is received. And what is this file transfer protocol and data? Here, this FTP data connection. The port number is 20. And for the FTP connection, here the port number is 21. For Telnet, it is a terminal network, and the port number for the Telnet is 23. And now we'll see what is meant by this full duplex communication. This TCP is going to offer you. The first one is the service. The first service is the process communication, and the second service is the full duplex communication. Always, whenever in our mind, what is meant by this full duplex? Here, if we have the transmission, both the ends at a time, then we are going to call it as a full duplex communication. Here also, this TCP is going to offer you the full duplex service in which the data can flow in both directions at a time. And each TCP has a sending and receiving buffer, and segments move in both the directions. Okay. And the third service is here it is a connection-oriented service. In our first session only, we have learned the best example for the connection-oriented service is the TCP. Here, when a process at site A wants to send and receive a process at site B, then here, the first it is going to create one virtual connection. Okay, then only the data can be exchanged in both directions. And once the data transmission has been completed, the connection is going to be removed. Okay, it is a connection-oriented service. And here, now the same, here the TCP segment is encapsulated in an IP datagram, and it can be sent out to the out of the order or lost or corrupted must be received. Okay, and it is going to provide a stream-oriented environment for the transmission of data. And it is the accept of the responsibility of delivering in bytes. Okay, and next here, we have the other important service is the reliable service. Here, the TCP is a reliable transport protocol. It uses an acknowledge mechanism to check the safe and sound arrival of data. Now, what is the other fifth service is what we have? Stream delivery service. Here, this TCP allows the sending process to deliver data as a stream of bytes and allows the receiving process to obtain the data as a stream of bytes. And the sending process produces a stream of bytes and the receiving process consumes it. Okay. And now here we'll see some other concepts which are related to our TCP. Here we have the sending and receiving buffers are there. That means the TCP, this transport control protocol, it needs the buffers for storage because the sending and receiver processes may not write or read the data at the same speed. Sometimes the client is sending 10 packets at a time, but the receiver is receiving only 5 at a time. Then what about the remaining 5? For that reason, we should maintain one buffer. Okay, the buffers are implemented by using the circular array with where each location carries 1 byte. Okay, and there are 2 types of buffers. We have the sending buffer as well as the receiving buffer. Okay, and here you just say here is the sending buffer. It is going to store the data. The process is sending one after the other. Okay, then the buffer is going to send one after the other based on the requirement. And sometimes if it is sending 5, but it is receiving is 3. One after the other it is going to receive and it is going to store and send. Okay, this is a sending and receiving buffers. Okay, and now what is meant by this segment? The TCP groups a number of bytes together into a one packet that is called as segment. And the TCP is going to add a header to each and every segment and it is going to deliver to the IP layer for the transmission. And here each and every segment are encapsulated in IP datagrams, then it is going to be transmitted. And the segments are not necessarily the same size. Okay. And what is meant by the TCP features? Numbering system, flow control, congestion control, error control. These are all comes under the features of the transmission control protocol. Now, what is meant by this numbering system? Here for each and every TCP number, we have a byte as well as a sequence. Then we have the acknowledgement number. Okay, that means then only it is going to form one complete number for the transmission of data. Next, what we have, what is meant by this byte number? All data bytes that are transmitted in a connection will be given a number called byte. Okay, and here it is going to transmit in each direction, and here it will starts with 0 to 2 power 32 minus 1. Okay, next, what is meant by the sequence number? After the bytes have been numbered, TCP is going to assign a sequence number to each segment. Okay, that is to be sent. The sequence number for each segment is the first byte number of carried in that segment. Now, what is meant by this acknowledgement number? It defines a number of the next byte that the party expects to receive. The acknowledgement number is used to confirm the bytes that have received. And next here, the acknowledgement number also will be same as a byte. Now, what is meant by this? Flow control and error control. See here, whenever if you have learned about the UDP, there we have the no flow control, no error control mechanism is there. But whenever you are learning about the TCP, here we have a concept called flow control and error control. And this, if the flow is more, it is going to maintain the buffers also for the TCP. And the TCP is going to provide the flow control. The receiver of the data controls the amount of data that is to be sent by the sender. And this is done to prevent the receiver from being the overwhelmed with the data. And the numbering system allows the TCP to use a byte-oriented flow control. And what is meant by this error control here? This transmission control protocol is going to implement the error control mechanism to provide the reliable service. And error control is always a byte-oriented. And error control considers a segment as a unit of data for error detection. What is meant by this congestion control? This TCP takes into account the congestion in the network. The amount of data to be sent by the sender is not only controlled by the receiver, but is also determined by the level of congestion in the network. Okay, and see you in the next session. All the best.